So now that you've watched the video and looked at different ways to describe motion of an object to someone, looking at things that move forwards and backwards, fast and slow, and just again describing that in words that we're comfortable with. Today we're going to talk about more specific vocabulary. So the title of our notes today will be Motion Vocabulary, and our question is going to be, what terms can we use to accurately describe the motion of an object? So the first two terms that we need to talk about are actually not physics specific, but they're actually more math related. So we need to talk about what a scalar quantity is and what a vector quantity is. So a scalar quantity is something that has only magnitude. And magnitude is really just size. So it's just a number. And an example of scalar might be 2 pounds or 40 miles or 12 seconds. So it's just a thing. So by comparison, scalar things are relatively simple. So that's how I remember it. Scalar is simple. Vector things are a little bit different. So vector quantities have both magnitude, but it also includes information about direction. So what way is the object going? So magnitude and direction. So an example would be 100 miles north or 2 feet to the right. But we're not only saying how far and how much, but also which way. So it's more specific. So scalar is simple, vectors are specific. So all of our variables are either going to fall under that scalar description or they're going to fall under the vector description. So I'm going to set up a table to keep them apart, and then we're going to go through 5 basic physics vocabulary terms. So the first two we're actually going to look up as a set of terms. So there's a scalar and a vector version of that scalar quantity, if you will. So the first one, it's very simple. We're just going to talk about distance. And distance is exactly what it sounds like. It's simply how far you traveled. And so we can see how that would be a scalar quantity, because if I asked you how far you drove today, you might say 10 miles, right? That's all you're giving me. And that doesn't tell me a whole lot other than how far you live from the school or how far away you are. So the vector version of distance is something called displacement. And displacement is not only how far you traveled, but in what direction. And so what we're really looking at is how far are you from where you started. So are you 10 miles north of where you started, or are you 5 miles south? So we're always looking at how far have you been displaced from your origin point. And if you remember from chemistry or even middle school, when you put an object in a test tube of water or an Erlenmeyer flask, and we measured the displacement, by how much did adding the water change the volume? And the difference between distance and displacement is something that we're going to explore both in some graphical ways. We'll explore it physically through an activity, and it's something that we'll bring up throughout the lesson. So that's our first pair of words. The next set of words that we're going to look at are speed and velocity. And these ones are easy because they match up with the letters. So speed is the one we're probably most familiar with, and that's a scalar quantity. And in simple terms, speed is simply how far and how fast. So what is the distance you traveled and how long did it take? And so since distance is scalar and time doesn't have a direction, it's also scalar, speed ends up being a scalar quantity. So what distance did you travel and how long did it take? And so if speed is our scalar quantity, then velocity, the V, is our vector quantity. And if we used distance and time to determine speed because they are scalar, then for velocity we're going to use displacement. So instead of distance, velocity is a measure of displacement in a period of time. So we would call that actually a rate of change in your position in a period of time. And so the next one, these two are not a pair, but I did mention it, so I wanted to add it. Time is in fact a scalar quantity, and it's always a scalar quantity, right? Time doesn't go forwards and backwards, at least not in this class. So we'll always consider time to be scalar. And our last term for today is going to be our last vector quantity, and that's something called acceleration. We're mostly familiar with acceleration in terms of cars, maybe athletes, but acceleration is a vector quantity. And we typically think of acceleration as that idea of speeding up, right? And if you speed up, it is your velocity that changes, right? You got faster, so your speed changed, but you also did so in a particular direction, typically going forward. And we'll spend a lot of time really clarifying and understanding the exact definition of acceleration. But for today, we're going to define acceleration as a rate of change in the velocity of an object in a period of time. All right, so we've wrapped up our notes for today. So the first one would be pretty short, and you've already done an activity. So I want to talk just a little bit about the Cornell format. So obviously we had our title and our question, and then when we talked about scalar and vector, I kind of gave myself some notes on the side. But what I want you to think about and maybe include in this left-hand space is some examples that you've used. So thinking about speed or velocity, and then looking at maybe acceleration. And in the left-hand column, just jot down some things that are going to help you keep those organized, right? Speed and velocity are very similar, but they're wildly different things in physics and especially mathematically, as are distance and displacement. So in the side on the left, try to give yourself some examples that you think fit into these terms, and then when we come back together next, we'll talk about your examples and we'll decide if you're using the right terms or not. The last thing that we do with our Cornell format is to summarize. So that last box on the bottom, that space there, because we just took one page of notes, is going to be your summary. And sometimes you're going to summarize the notes. This is just vocab. So what I want you to think about in your summary today, and the question I want you to consider, is, do you think, so kind of your own reflection, maybe thinking about the activity that we completed with the videos, are you currently using these terms correctly when you talk about motion? So when you say speed, are you actually talking about speed? And when you talk about distance, I don't know how many use displacement, but again, just kind of reflecting on how you're using the terms in your current language, and are you really using them in their physics definition? And that's your summary. When we get back together, we're going to review the vocab and take some time to really start diving into what they mean and what it looks like for us in the real world and for in physics.